Okay, so neutron stars and black holes. So Nick just read about the neutron stars and black holes. At this time, if you will just turn to the people at your table and discuss amongst each other some details that we could add to our Venn diagram. Okay? Just turn to each other and talk. Okay. I'm gonna walk around and check on them. Detail of neutron star.
How old are you?
What have y'all found?
We found two. One of
You think everyone open? Okay, 766.
something that they both have is they both occur when a higher mass star blows up or whatever. And the differences are black
Okay, so write that down. Yes.
They dropped pictures of what it's You know how it becomes like this way?
Oh my God.
You said it was dark in here, okay? There's just a little bit of light coming through the window. And you can't see me walking around, okay?
Like I was just saying earlier,
But if I walk in front of the window, I'm gonna block the light coming in the window. So you can't see me, but I can block the light.
that's possible.
So you know I'm there, right? That's just like a black hole. You can't see it, but you can tell that it's there.
It could be. That's what science is trying to find. Is there another solar system that has a sun similar to ours?
It's got a lot of stuff in it.
Well, yes, as you find them, write them. Okay.
You know the Earth has got gravity, right? And you know that there's satellites.
Right now we're just working on neutron stars.
And if they don't power the satellites, if the rockets lose their fuel, use up all their fuel, they're not going to be able to stay in orbit, and they'll come down Earth because of gravity. Well, the gravity of a black hole is very strong because it's got big mass on it, like bigger than all the planets, bigger than the sun and everything. So, and it keeps coming in, compressing, getting smaller and smaller and smaller. I'm talking about really small. It's like the whole solar systems come together in the smaller than the Earth.
You can do it.
Rather discuss. All right, you guys, stop for just a second. Just pause wherever you are. I want to hear from some of your discussion. Okay, so as far as a neutron star, Jeremy's group, give us a detail that you found in your reading.
It is visible.
Neutron star.
Oh, neutron star. Yeah, it's visible.
It's visible that you can see it. Okay, and the black hole.
It's invisible.
It's invisible. Okay. What about a both? A detail for both.
They occur after a high mass star blows up.
Very good. Okay. So if you don't have that, I would write that. It wouldn't hurt. So neutron star, you can see it. Black hole, it's invisible because you can even add to this. You can say it absorbs. I'm sorry. Hold on. The gravity is so strong, no form of radiation can escape it, including light. So basically, it's invisible. There's no light there. And a both would be that it comes from a high mass star that ends up as a supernova. Both of them do that. High mass star. They start as supernovas. There's a supernova and then it either becomes a black hole or a neutron star. Yes.
They measure only about 20 kilometers, 12,000 diameter.
Okay. Another detail, remind me name. Another detail Baxton's team found was that they measure only about 20 kilometers or 12 miles in diameter.
Where's my paper?
That's from the reading. Okay?
Do both of
There,
them?
one, you can, yes, add it. Okay, and another one that no one mentioned yet, maybe there's another team that has it. What is a neutron star? Anybody have the definition?
Core of a supergiant star.
Very good. The collapsed core of a supergiant star. You can add that. Write it down behind it. To be writing. I'm giving you information to write down. This is, you guys, this is one of your several study guides that I'm gonna allow you to use on your test on Friday. You will not be able to have the book. Therefore, if you don't fill in the information, guess what?
Let's open notebook.
You're gonna have, I'm gonna allow you to have your study guides on Friday. However, you need to study them. What we're writing down, you need to study them, because if you come in here Friday and have not studied them, you are not gonna finish the test in time. Because you're gonna spend too much time flipping through the study guides trying to find answers. And if you have blanks in your study guide and I'm trying to give you information to fill in the blanks, I'm sorry for you. Because you're not gonna get any help. You're not gonna be able to use your book. I'm giving you information. We're working together to get the information to fill it in. So you have something to use to study. That means tonight, tomorrow night, before Friday, study what we are writing down now. So that you'll be ready for the test. That way, when you're taking the test, you got number one, you read the question. Hopefully it will come to you, the answer. You see the answer there, if it's a multiple choice or a short answer, you'll be able to fill it, you'll be able to write it down. Then, if you get to a question and you're not sure about it, you'll know which study guide to go to right away. True. Because you have studied, right? Okay. That's my soapbox. Go ahead.
What are some for black holes again?
Say it again.
What are some details for black holes?
Okay, what's the detail for black holes? Somebody shared that earlier. Andrew.
The gravity is so strong that they pull in all forms of radiation.
The gravity, Andrew was just saying the gravity is so strong that no form of radiation can escape it, including light. Okay?
I got another level 5.
Braxton?
Baxter.
Baxter. Okay, Baxter.
The core collapses even further than a neutron star.
Yes. The core collapses, Baxter said the core collapses even further than a neutron star. That's another detail that's important about a black hole. The core collapses, Andrew, for a black hole, the core collapses even further. Pick up the pencil. Did you write it down? Do you have that detail?
What?
The core collapses even further than a neutron star for a black hole. That's a detail. The core collapses even further than a neutron star. Where's your why are you not where we are? Okay, we already wrote the both. They both come from a high mass star that ends up as a supernova. High mass star that's a supernova before it becomes one of them, right? It starts as a high mass star.
High mass star supernova.
That is a supernova that becomes a supernova. And I'm not just pulling that out of the sky. That's on your handout for life cycle of a star.
Wait, are those two different details or
That was the both. It's just one. If you look at the bottom of your handout, high mass stars. We go from nebula to protostar to main sequence star or blue giant, then the red supergiant, then the supernova. That's explosion. After the supernova, a high mass star would either become a neutron star or a black hole. That was the both. Okay. Number 7, why do astronomers need to use special methods to detect star systems? Let's turn to page 768.
760. May I read?
Okay. Hold on a second. Samantha, right? Yes. Samantha, read star systems.
Unlike our sun, most stars.
Everyone should be on page 768 and read along, please.
Our stars do not exist alone. Instead, they are grouped with one or more companion stars. The stars are held together by the force of gravity between them. A binary star system consists of two stars that orbit each other. A multiple star system consists of more than two stars.
Stop for a second. Binary, that means two. Two, okay? So basically what it's saying, you know, in our solar system, we just have the one sun, but there are others that have more than one sun, or more than one star in that system, that star system. Okay, and so to find, to detect those star systems, one way is, if you see the square on the side there, binary star system, they're showing you a diagram of two stars. One just happens to be a little smaller, so you can see the difference of if they're looking with a telescope, with a high-power telescope, and they see they see a star, and they notice that it dims at a certain time, and then it gets brighter. Then that gives them the indication that there's another star passing in front of it. Okay.
Wait, is it like a radar?
I guess it kind of would be. I'm not sure if it would be radar, but basically the telescope they would notice a difference in the light as the other star is passing in front of it. And so that's how they would know that it's a binary star system.
Okay, but you said it would be like lighter or darker?
Yeah, it would get dimmer.
What's the same?
Okay, but just imagine. Imagine you have two things that are giving off light, one passing in front of the other. It's going to be light, dimmer than if you just see two bright lights, right? Yes. All right, so did you read on? Who was just reading? Samantha, continue reading. That second paragraph.
In many star systems, the stars are too close together to be seen individually. However, astronomers have developed ways of detecting such systems. For example, in a binary star system, one of the stars may orbit in front of the other when viewed from Earth. The star that orbits in front will briefly block some of the other star's light, providing a clue that more than one star is present. The illustration at right shows a binary star system that can be detected this way. Sometimes astronomers can also figure out whether a star is really a star system by studying its spectrum.
Continue.
Star systems are an important source of information about star masses. Astronomers cannot measure the mass of a star directly. However, they can figure out a star's mass by observing the effect of the star's gravity on the companions.
Okay, so was anyone able to pull out a detail there that we could use as an answer for number 7? Why do astronomers need to use special methods to detect star systems? John.
In many star systems, the stars are too close together to be seen individually.
Yes, perfect. So stars are too close together to be seen individually. Okay. You can add to that, and we cannot see them easily with our bare eyes. Bare meaning no telescope, no other instrument. Yes. Stars are too close together to be seen individually. It's in the beginning of that second paragraph. Right here. This really about what you said. You said you can wait? Okay. All right. Stars are too close together to be seen individually, and we cannot see them easily with our bare eyes. Okay. Everybody got it?
Yeah.
All right. We have 20 minutes, right? Okay. 23 minutes.
20.
Can you
Okay.